Hey guys, good evening and welcome back. Welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Let me know quickly in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats. Everybody. Quickly let me know in the chats. Good evening, people. Good evening, good evening, good evening. I think the camera adjustment is not up to the mark. Just a second, guys. Let me just fix it. Just a second. Now I think it's better. Is it? Is it better now? Is it better now? Say it in the chats once. Or it's the same. Let me just check it once. I think it's okay now. Lighting, everything is perfect. Yeah? Perfect, perfect, perfect. So people, call up all your friends. Call up all your friends because this is going to be a super important session, right? We are going to discuss some amazing questions of the chapter chemical bonding. And my dear students, this particular session will include all the questions which are in your NCERT textbook, right? In-text questions, NCERT exercise. Then you have got your NEET PYQs, JEE Mains PYQs, every single type of the question I have come up with in the today's session, right? And I believe if you all have watched the marathon of this particular chapter, which I took, I think a month before, right? I believe you should be in a position to solve each and every single question on your own. Okay? So are you all ready? Are you all ready, people? Are you all ready? Let me know in the chats. Are you all ready? Quick. Everybody in the chats. Everybody in the chats with some fire emojis. And I would want you guys to be active in the chats completely, okay? Completely, I want you guys to be active in the chats. Because the questions you guys are going to solve. Okay? Perfect, perfect, perfect. Perfect. Just give me a second. Perfect, guys. So let's get going then. Let's get started with this particular question practice session. Just give me a second once. Let me check if the marker is fine. Yeah. All right. So people, without wasting any sort of time, let's get going. Let's get started with the first question, which is on your screen. I want the chats to be running continuously. I want the chats to be running continuously. Look at the question and give me the answers in the chats. I do not want any spamming in the chats. The ones who are typing, I don't know what kind of nonsense stuff, you guys can leave my session, okay? Just focus on what I'm saying. All right, people. Look at this particular question. The correct sequence of increasing covalent character is represented by. The correct sequence of the increasing covalent character is represented by. What do you think of this particular question? What do you think of this particular question, people? What do you think about this particular question? This is something which you should be able to solve. This is something which you should be able to solve. Well, a lot of people are saying option 4. A lot of people are saying option 4. Is that? Is that? Is that? Check the question carefully. The correct sequence of increasing covalent character is represented by. My dear students, this is the question based on your Fajan's rules. This is the question based on your Fajan's rules. Well, if you talk about your LiCl, over here you have got Li positive and Cl negative. NaCl, Na positive, Cl negative. BeCl2, this is going to be Be di positive, Cl negative. Right? Well, people, your covalent character depends on polarizing power of cation. You know it. And polarizing power of cation, it depends on charge on cation as well as the size of cation. You must be knowing polarizing power of your cation is directly proportional to the charge on cation and inversely proportional to the size of cation. Right? Now, where do you think the charge on the cation is maximum? I can see the charge on cation is maximum in this particular case. Right? Wherever the charge on cation is maximum, maximum is going to be the polarizing power of cation. More the polarizing power of cation, more is going to be the polarization. Hence, more is going to be the covalent character. Right? Hence, more is going to be the covalent character. So, BeCl2 is going to be maximum covalent. BeCl2 is going to be maximum covalent. Now, in case of your LiCl and NaCl, have a look. Your anion is same here. So, do not check the anion because it's same. Li positive, Na positive. Both have got equal charge. The charge of cation is same. Now decide on the base of size. Lesser the size of cation. Lesser the size of cation. More the polarizing power of cation. More will be the covalent character. So I would say over here, I should write LiCl. And here, I should write NaCl. So which option satisfies it? Tell me in the chats. What do you think is the correct answer now? What do you think is the correct answer now? What do you think is the correct answer now? Absolutely, it's going to be option C, which is going to be the correct answer of this particular question. Right, people? Okay. All right. Have a look on this particular question. This is something which I believe everybody should solve on your own. Because it's not something difficult or, right? It's not something wherein calculation is involved. This is the easy kill question, guys. Easy kill question. Quickly. Well, I can see majority of the students are coming up with option, which one? Option C. Is that? Is that? Harry Potter, you're disturbing the session, bro. Go and check Game of NEET 2.0 series or 1.0. You'll get to know what kind of content is here on this particular channel. I'm blocking you, sorry. I don't know who has sent you here. Okay, look at this particular question. Among the following, the electron deficient compound is. Which of the following is electron deficient? If you look at the first example, your BCl3. If you talk about your BCl3, my dear students, in case of your BCl3, if I ask you, how many electrons do you see here in case of boron? How many electrons do you see in the outermost shell of boron here? 2, 4, 6. So boron in its outermost shell, there are 6 electrons, right? And it should have 8 electrons, but there are only 6 electrons. So I would say your BCl3, it is electron deficient over here, right? Because in the outermost shell, there should be 8 electrons. But over here, in case of the central atom, in case of boron, it only has got 6 electrons in its outermost shell. So it clearly indicates it is electron deficient. One simple and basic question again this was, and I have seen majority of the students have come up with the right answer. All right, people, look at this particular question. Again, the question based on your Fajan's rule, and this question has been asked your JEE Mains 2022 attempt. Yeah, JEE Mains 2022, and proper NEET standard question this is, and I believe you can easily solve this sort of a question on your own. I'm pretty much sure about that. I am pretty much sure about that. Arrange the following in the increasing order of their covalent character. Arrange the following on the increasing order of their covalent character. First of all, I want to see your answers, then I'll solve the question. First of all, I want to see your answers, then I'll be solving the question. This is again the easy question. It should not take more than 15 seconds to solve, guys. This sort of a question should not take more than 15 seconds to solve. Let me be very honest. All right, majority is coming up with option 2. Is that? Let me exactly check whether you guys are right or wrong. So first of all, we are given with CaF2. We are given with CaCl2. We are given with CaBr2. And at the same time, we are given with CaI2. These are the compounds which we are given with. Now, my dear students, this is calcium dipositive here. This is F negative. Calcium dipositive, Cl negative. Calcium dipositive, Br negative. Calcium dipositive and I negative. So in all the cases, if you see, your cation is same. Your cation is same. So I'm not going to decide on the basis of cation. I will be deciding on the basis of anion. The charge on every anion here is same. The charge on every anion here is same. Right? So I'm not going to decide on the basis of charge on anion. I will be deciding on the size of anion. Where is the anionic size maximum? Anionic size is maximum in this particular case. I negative has got maximum size among all these anions. More the size of anion, more the polarizability of anion. And more the polarizability of anion, more is the polarization. More the polarization, more is going to be the covalent character. Right? So this is going to be the order of the covalent character of this particular question. Now we can select your options. Right? D has got maximum, followed by C, followed by B, followed by A. So it has to be option 2, which is the correct answer of this particular question. All right. Look at one more question, which is again asked in JEE Mains 2022. Proper NEET standard question this is. Proper NEET standard question this is, people. Check it out. Check it out quickly. This is something which you should be again able to solve on your own. LiCl, NaCl, KCl, CSCl. Okay, you have to arrange them on the basis of their covalent character. What do you think is the correct answer of this question? Quickly. Quickly, people. Quickly, everybody. Well, I can see majority is coming up with option 2 and option 3. Let's exactly check what is going to be the correct answer of this question. Oh, some are saying option 4 as well. All right. Let's check it out. Again, I have to arrange them on the basis of their decreasing covalent character. My dear students, first of all, look at the charges. Li positive, Cl negative. Na positive, Cl negative. K positive, Cl negative. Cs positive, Cl negative. Anion everywhere is same. So do not decide on the basis of anion because anion everywhere is same. Now talk about cation. The charge on every cation here is same, right? So I'm not going to decide on charge on cation, right? I'll be deciding on size of cation. Lesser the size of cation, more the polarizing power of cation. More the polarizing power of cation, more is going to be the covalent character, right? So this cation has got the least size. So I would say LiCl has got maximum covalent character, followed by your NaCl, followed by your KCl, followed by your CSCl. This is the decreasing order of the covalent character, right? This is going to be the decreasing order of your covalent character. Now, accordingly, you can select your options over here in this particular case. I believe I'm clear with this. All right. One more question that has been asked in your JEE Mains 2021. And again, this is something which you should be able to solve on your own. Quickly, people. This is the assertion reasoning question, wherein if you look carefully, assertion says lithium halides are somewhat covalent in nature. Lithium halides are somewhat covalent in nature. Is this statement true? Is this statement true? The statement is absolutely true, guys. Lithium halides are covalent in nature. Reason: lithium possesses high polarization capacity. And it is evident in case of when you talk about your lithium halides, when you talk about lithium, basically, lithium is the one which has got the smaller size. Smaller the size, more the polarizing power of the cation. More the polarizing power of cation, more is going to be the covalent character. So absolutely reason is true, as well as the reason is the correct explanation of the assertion. Right? As well as reason is the correct explanation of the assertion. So option 4 has to be the correct answer of this question, which I can see majority of the students have already given right. Perfect, guys. All right. A question from again Fajan's rules asked in NEET 2020 examination. Look at the question. What is the correct order of decreasing ionic character? What is the correct order of decreasing ionic character? You know, covalent character is inversely proportional to the ionic character. This is something which I believe all of you would be knowing by now. Okay? So let me give the covalent character order and I'll reverse that order at the end. I'll be getting the ionic character order, right? Decreasing order of ionic character. Decreasing order of ionic character. So first of all, if you look at all these cases, you have got PbCl2, you have got PbF2, you have got PbI2, and you have got PbBr2, right? Now, first of all, if you look at the charges on these species, it is Pb di positive Cl negative, Pb di positive F negative, Pb di positive I negative, Pb di positive Br negative. So cation everywhere is same. So don't decide on the basis of cation, right? Cation everywhere is same. Now talk about the anion. The charge on every anion is same. The charge on every anion is same. Now, talk in terms of size of anion. Where is the size of anion maximum? I negative has got maximum size, followed by Br negative, followed by Cl negative, followed by F negative. So this particular I negative, it has got maximum size. Maximum size means maximum polarizability. Maximum polarizability means maximum covalent character. So I would say PbI2 has got maximum covalent character, followed by your, it's going to be PbBr2, followed by, it's going to be PbCl2, followed by, it's going to be PbF2, right? This is the covalent character order. If this is the covalent character order, what is going to be the ionic character order? Just reverse it. Ionic character order is going to be PbI2. Here it's going to be PbBr2. Here it's going to be PbCl2. And here it's going to be PbF2. This is the ionic character order. This is the increasing order of the ionic character. This is the increasing order of the ionic character. You have to mention them as per decreasing order of ionic character. What is going to be the decreasing order of ionic character? PbI2, PbF2 has got maximum ionic character, followed by PbCl2, followed by PbBr2, followed by PbI2. Perfect. So I believe you can easily select your options now. I gave you the concept, right? So as majority of the students were saying option 4, absolutely it's going to be the option 4, which is going to be the correct answer of this particular question. All right. Look at this particular question, guys. Again, the question based on your Fajan's rules. I'm giving you the questions topic-wise here. First, I've selected the Fajan's rules. After this, we'll be going on to one more topic. Select the most ionic and most covalent. Most ionic means less covalent. Most ionic means less covalent. So I have to select less covalent and more covalent. Less covalent and more covalent. Less covalent and more covalent. First, there should be less covalent. Second, there should be more covalent. Now, people, understand. And this is something which is pretty much simple. I believe all of you would be already knowing. If you look at second option, second option, this is Pb di positive, O di negative, right? Manganese here is in +7 oxidation state. Oxygen here is in -2 oxidation state. Perfect. Now people, anion is same. Talk about cation. Charge on cation here is more. Charge on cation is more. That means more polarizing power, more covalent character. So this is more covalent. This is more covalent. Automatically this becomes less covalent. This is more covalent. This becomes less covalent. Less covalent means more ionic. So this is more ionic, and this is more covalent. This is something which I was supposed to check. More ionic, more covalent. More ionic, more covalent. So it has to be option 2. That is going to be the correct answer of this particular question. Absolutely. All of you are given the correct answer. Amazing. Good job done. All right, people. Now let's have a look on the questions based on your dipole moment and bond polarity, right? Dipole moment and bond polarity. Again, from this particular topic, questions are frequently asked. Okay. Look at the first question. NEET 2020. NEET 2020, people. Give it a try. Quick. Which of the following set of molecules will have zero dipole moment? Which of the following set of molecules have got zero dipole moment? This question I have solved many a times in case of your marathons. You know it. And you should be able to solve this on your own. You should be able to solve this question on your own. Which of the following has got zero dipole moment? Zero dipole moment. Quickly. Well, if you have forgotten, let me tell you. The molecules of the type AB2L0, AB3L0, AB4L0, AB5L0, AB6L0, Ab2L3, Ab4L2. I've told you, if you remember, these are the molecules which are having net dipole moment equal to 0. That means these molecules are going to be non-polar. These molecules are going to be non-polar in nature. You should know it by now because we have discussed this in detail. Now, boron trifluoride, BF3. If you talk about your BF3 is of the type AB3L0. It is of the type ABL0. Hydrogen fluoride, HF. It is, guys, it has got dipole moment, right? It's polar. So this cannot be the answer, right? Even this cannot be the answer. Look at the third option. Here you have got BF3, which has got net dipole moment 0. BEF2. This is the molecule of the type AB2L0. Perfect. Comes into the category. Carbon dioxide, CO2. This is the molecule again of the type AB2L0. Okay. And 1,4-dichlorobenzene. Again, its dipole moment is 0. And it has to be option C, which is going to be the correct answer of this particular question. Right? Perfect, guys. All right. What do you think about this one? NEET 2019. NEET 2019. Which of the following is the correct order of dipole moment? Which of the following is the correct order of your dipole moment? Dipole moment. This is something which I've already told you. More the electronegativity difference between the atoms, generally more is the dipole moment. More the electronegativity difference between the atoms, generally more is the dipole moment. Right? So what is the answer? What is the answer? Where is the electronegativity difference more between the atoms? My dear students, OH electronegativity difference is more than that of NH, is more than that of NF, is more than that of BF. Right? So basically H2O will be having maximum dipole moment. H2O will be having maximum dipole moment. Now, among your NF3 and NH3, which one has got more dipole moment? This is something which we have discussed. I hope you remember. This is something which we have discussed. NF3 and NH3. If you talk about the structure of your NF3, this is how your NF3 looks like, and here you have got the lone pair, right? Similarly, your NH3, this is how your NH3 looks like, and here you have got a lone pair, right? Now, my dear students, you should know lone pair also contributes towards the moment, and the direction of the moment due to lone pair is towards the lone pair. It is towards the lone pair, right? Over here, less electronegative to more electronegative. Less electronegative to more electronegative. Less electronegative to more electronegative. Less electronegative to more. Less to more. Less to more. If you look at this particular case, do you see all the moments are converging in one direction? Over here, there will be some kind of cancellations as well between the moments. One is upwards, someone is downwards, etc., etc. So there'll be cancellations here. There won't be any sort of cancellations here. So net dipole moment of NH3 has to be more than that of NF3. So I would be considering NH3 first. After that, I'd be considering NH3 first. And here I'll be writing NF3. And at the end, it's going to be BF3 that has got the zero dipole moment. So this is the order. Now you can select your option. It has to be option C. Right? Perfect, guys. Let's move on to one more. The question asked in your NEET 2018. The question asked in your NEET 2018. Look at the question. Which of the following is the correct order of dipole moment? Wait, I think... Which of the following is the correct order of dipole moment? The question is wrong here. It should not be this. It should not be this. The question should be something different. I think it's a mismatch. Basically, the question was like this. It's a mismatch here. Okay. The question was something related to boron, as far as I remember. In NEET 2018, the question was asked related to BCl3. Related to BCl3, the question was asked. Something, it was like this. BCl3 was the question asked. And it was asked like, what is its net dipole moment? And you should be knowing the net dipole moment of this particular one is 0. right? Some sort of question was asked like this. Anyways, you leave the question as such. It's a mismatch here. It's a mismatch here. All right, look at this one. Which of the following is a polar molecule? Which of the following is a polar molecule? Quick, everybody. Which of the following is a polar molecule? Which of the following is a polar molecule? Check the type of the molecules first. Check the type of the molecules first. SF4, it is of the type AB4L1. SIF4, it is of the type AB4L0. XEF4, it is of the type AB4L2. BF3, it is going to be AB3L0, right? And this particular set, AB4L0, AB4L2, AB3L0, their net dipole moment is 0. If their net dipole moment is 0, that means they are going to be non-polar. What am I supposed to check? Which of the following is a polar molecule? So it is directly going to be SF4, which is going to be the polar molecule among all. I believe I'm clear with this. I believe I'm clear with this question, people. This is something which is given you an NCERT exercise. And I believe you should be in a position to let me know the answer of this particular question. Which out of NH3 and NF3 has higher dipole moment? Few minutes back we discussed. This question is given in your NCERT exercise. This sort of a question you should be able to solve. I mean, there is no need to solve. We have solved this question before. We saw a few minutes back, your NH3, it has got more dipole moment than your NF3. This is something which we discussed few minutes back when I showed you the structures of your NH3 and NF3. In case of NH3, there are no cancellations. In case of NF3, there are some cancellations of moment. So net dipole moment in case of NH3 is more. Few minutes back only we have discussed. Absolutely, it's NH3. Wonderful. All right. Look at this one. The question has been asked in JEE Mains 2022 and it was the integer based question and you should be in a position to solve this question on your own now. You should be able to solve this question on your own. You should be able to solve this question on your own. My dear students, first of all, you have got BEF2. Check the types of each molecule. BEF2. BEF2. It's going to be AB2L0 type and AB2L0 type, its net dipole moment has to be 0. Right? Its net dipole moment has to be 0. Second is your BF3. You just have to check the type of the molecule. Type of this molecule is AB3L0. So again, its net dipole moment is 0. Right? In case of H2O, right? In case of H2O, what is the type of the molecule? The type of the molecule is AB2L2. If the type of the molecule is AB2L2, it is non-zero. Its net dipole moment is non-zero. In case of NH3, what is the type of the molecule? It is AB3L1. AB3L1 does not have net dipole moment 0. Now we have got CCl4. CCl4 is of the type AB4L0. And you know AB4L0, its net dipole moment is 0. Then you have got HCl. And HCl, all of you would be knowing, its net dipole moment is non-zero. I have to check which of the following molecules, the number of molecules with non-zero dipole moments. Non-zero. Non-zero means this one, non-zero means this one, and non-zero means this one. So the answer of this particular question is going to be 3. So there are 3 molecules which are having non-zero net dipole moments in this particular case. Right? It was the integer based question asked in your JEE Mains 2022 and proper NEET standard question this is. Okay? Perfect. I am moving on to one more question, guys. Look at this. Again, the question asked in your JEE Mains 2023 and proper NEET standard question this is. And you know, 20% of your NEET paper is directly copy paste of your JEE Mains PYQs. You should be knowing that. Okay? Almost 20% of your NEET paper is directly or indirectly asked from the PYQs of the JEE Mains examination. That's why I come up with these JEE Mains PYQs as well. All right. Statement 1, statement 2. Statement 1 shows that dipole moment is a vector quantity. Perfect. Yes. And by convention, it is depicted by a small arrow with a tail on the negative center and the head pointing towards the positive center. Is that right? In chemistry, dipole moment representation is from positive to negative, right? So this is the dipole moment representation, positive to negative in chemistry. In chemistry. So this statement is incorrect. Statement 1 is incorrect. They are just telling the reverse. The crossed arrow of the dipole moment symbolizes the direction of the shift of the charges. Absolutely, this arrow symbolizes the direction of shift of the charges in the molecule. That's correct. So statement 1 is incorrect and statement 2 is correct. Statement 1 is incorrect and statement 2 is correct. Statement 1 is incorrect and statement 2 is correct. So it has to be option 2 that is going to be the correct answer of this particular question. Okay? Absolutely, guys. All right. Again, one question which has been asked here at JEE Mains 2020. And you should be again in a position to solve this particular question as well. Decreasing order of dipole moments. CHCl3, CCl4, CH4. What do you think? First of all, if you talk about your CCl4 and CH4, CCl4, CH4, their type is what? AB4L0. If their type is AB4L0, so they should have net dipole moment 0. So their dipole moment has to be same and 0. CCl4, their dipole moment, CCl4 and CH4, their dipole moment has to be 0, right? Which is the minimum, That means which option satisfies it? Option A. Both of them have got 0 dipole moments minimum. So CHCl3 automatically will have more dipole moment than them. Yeah? It is simply option 1. A simple question which I believe every one of you can easily solve, guys. Easily means easily. Now, let's see the questions which have been asked from the topic, your VBT, valence bond theory, bond length and bond energy, right? Let's see what kind of the questions have been asked. Okay, this is the question which has been asked in your NEET 2013. The outer orbitals of carbon in ethene molecule can be considered to be hybridized to give 3 equivalent sp2 hybrid orbitals. The total number of sigma and pi bonds in ethene molecule is. Ethene, guys. This is how your ethene looks like. This is how your ethene looks like. You have to check your sigma and pi bonds. First of all, this is your sigma, 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 sigma. So 1, 2, 3, 4, 5. So there are 5 sigma bonds and this one is your pi bond here. So 5 sigma and 1 pi. 5 sigma and 1 pi, right? So option D. Again, a simple and basic question this is, which I believe you all can easily solve. All right. Look at this question, guys. Even this sort of a question you should be in a position to solve easily. Again, less than 10-second question. Which of the following molecule contains no pi bond? Which of the following molecule contains no pi bond? Look at the first option itself, water. Structure of water, everybody knows. This is the structure of water, right? 2 lone pairs. Do you see any pi bond here? Do you see any pi bond in water? No. So directly, no need to check the rest of the options. It's option 1, right? It's option 1. No need to waste your time. Structure of O3. AIPMT 2008. Structure of O3. When I showed you the Lewis structures in the chemical bonding chapter, I've discussed about the structure of your O3. Okay? I've discussed the structure of your O3. And O3 contains what? As per its structure, it contains 2 sigma, 1 pi. Right? It contains 2 sigma, 2 sigma and 1 pi. In case of O3 molecule. This is something which I believe you all would be remembering by now. Okay. PP overlapping will be observed in which of the following molecules? PP overlapping would be observed in which of the following molecules? H2 molecule, HBr molecule, HCl molecule, and Cl2 molecule. Where do you see PP overlapping among all these cases? Where do you see PP overlapping, people? First of all, over here it is 1s1, 1s1. So it is going to be SS overlapping. SS overlap in the first case, right? This is S and it is basically P5 configuration. This bromine, P5 configuration, right? Perfect. P5 means one of the p orbital is half filled. Perfect. So it is going to be sp overlap here. Similarly, here it's going to be sp overlap. In this particular case, it is p5, p5. So it's going to be pp overlap. This is again something which we have discussed in detail in the marathon itself. So it has to be option D. Okay. I believe it's clear. All right. Look at this particular question and tell me the answer of this question quickly. Everybody. Everybody in the chats. Everybody in the chats, people. Quick. Everyone. The angle between the overlapping of 1s and 1p, 1s and 1p is going to be 180. Right? No need to think about this question. No need to think about this particular question. Which of the following represents zero overlap? Which of the following represents zero overlap? My dear students, positive, positive. Same sign on same side. So it is a positive overlap. It is a positive overlap. Positive, negative. Opposite sign on same side. It is the negative overlap. Look at this particular case. Do you see any overlap here? Your P and S. There is zero overlap here. So option C has to be the one which is correct. So zero overlap here in case of C. So same sign, same side means positive overlap. Opposite sign, same side means negative overlap. Right? Perfect. All right. Moving on to one more. A simple basic question this is. I believe everybody should solve this one. What is correct order of bond energy? Bond energy. Bond energy. Carbon triple bond carbon has got more bond energy, right? Then carbon double bond carbon, then carbon single bond carbon. You should know it. More the bonds in between, more the bond energy. More the bonds, that means more the force of attraction. More energy is required to break it. That means more the bond energy, in short. So it has to be option D. All right, this particular question. This particular question, quick, everybody. The molecule not having pi bonds. My dear students, I believe you know the structure of all of these molecules. Carbon dioxide, this is your CO2, N2, N triple bond N, O2, O double bond O, Cl2, Cl single bond single. Which of the following is not having any pi bond? It's going to be option A. Perfect? Absolutely. Wonderful. Now, let's have a look on the questions which have been asked from the topic hybridization and VSEPR theory. Hybridization and VSEPR. The first question which is your NCERT exercise question. Check it out quickly. Check it out quickly and let me know the answer. Everybody. Everybody in the chats. Quick. Everybody in the chats, quick. Everybody in the chats, quick. Oh, am I hiding some molecules? Sorry. I think it should be visible now. It should be visible now. Discuss the shape of the following molecules using VSEPR. Guys, it's pretty much simple. VSEPR we have discussed in detail. So first of all, you have got BeCl2. What is the type of this molecule? It is Ab2L0. So it has to be linear. BeCl3. What is the type of the molecule? Ab3L0. It's going to be trigonal planar. Trigonal planar. SiCl4 of the type Ab4L0. It has to be tetrahedral. Okay. Your ASF5. ASF5. The type of the molecule is Ab5L0. So it has to be trigonal bipyramidal. Perfect. Your H2S. H2S is like your water. H2O. Perfect. So it is bent. PH3. Of the type what? AB3L1. Like your NH3. AB3L1. It's pyramidal. Perfect. These are the respective shapes of these molecules which we're supposed to check. You just have to check the type of the molecule and accordingly you have to use the VSEPR and you can easily solve these questions. I believe it's clear. I believe it's clear. Look at this question. Look at this particular question, guys. Describe the change in hybridization of aluminum atom in the following reaction. We are given with a reaction and we have to see the hybridization of aluminium. So the reaction is your AlCl3 is finally getting converted into what? AlCl4. It is getting finally converted into AlCl4 negative. Perfect. If I talk about this aluminum, what is the type of this molecule? It is AB3L0. So how many sigma bonds it's forming? It's basically forming 3 sigma bonds, and there is no lone pair. 3 sigma bonds, lone pair, no lone pair. Steric number is 3 plus 0, 3. So your hybridization has to be sp2. So here the hybridization is sp2. Now, your AlCl4 negative, right? So first of all, how many sigma bonds? 4 sigma bonds. How many lone pairs of aluminum? 0 lone pair. Steric number, 4 plus 0 is 4. Hybridization involved has to be sp3. So aluminum is undergoing change in hybridization from sp2 to sp3 in this particular molecule, right? Even this sort of equation you should be able to solve on your own. Look at this one. It's again the NCERT exercise question, guys. NCERT exercise question. Considering x-axis as the internuclear axis. Okay, I'm considering this as the x-axis and I'm calling this as the internuclear axis. Okay, which of the following will not form a sigma bond and why? Which of the following will not form a sigma bond and why? This is your x-axis, right? If this is x, for example, this is going to be your y-axis. Let's say this is going to be your y-axis and perpendicular to it, it's going to be z-axis, right? So, if x is the internuclear axis, your s and your 1s and 2px, your 1s and 2px, they are going to do the head-on overlap, so it's a sigma bond, right? 2py. So this is your 2py, for example. This is going to be your 2py. It's going to be parallel overlapping, so they are going to lead to the formation of pi bond. 1s and 2s. This is 1s, for example. This is 2s, for example. 1s and 2s. It's always going to be a sigma bond. It's always going to be a head-on overlapping, right? So which out of the following will not form the sigma bond? So this out of the following is not going to form the sigma bond. 2py and 2py. All clear with this? Yeah? Are not going to form. Perfect. Perfect, guys. All clear? All clear with this? All clear with this question? I hope this is clear. All right. This is again one more NCERT exercise question and you should be again in a position to solve this one. The question is describe the hybridization in case of PCl5. You know, if you talk about your PCl5, what is the type of the molecule? The type of the molecule is AB5L0, right? Hybridization involved is sp3d, right? Which d orbital is involved in hybridization? It's dz square. What is the geometry predicted from hybridization? It's trigonal bipyramidal. This is something about PCl5. You know it already. We have discussed it in detail. Now, if you talk about, if you make the actual structure, this is P, this for example Cl, this is Cl, and this is Cl. So first of all, this is your equatorial plane. And perpendicular to them, what do we have? We have axial bonds. This is one Cl and one more Cl. So these are your axial bonds. The white colored ones are your axial bonds and the yellow colored ones are your equatorial bonds. And we have discussed in detail, if you remember, axial bond length here is greater than that of equatorial bond length. What is the reason for that? This particular bond length will be more than that of this particular bond length, right? Reason is because this chlorine over here, since this chlorine has got three lone pairs, right? This has got 3 lone pairs. Even this has got lone pairs. Perfect. So there will be repulsions between equatorial chlorine atoms and axial chlorine atoms. If there are repulsions between equatorial and axial chlorine atoms, so the chlorine at the top, it will go up. So its bond length will comparatively increase, right? Again, a simple question this is. And we have discussed this as well, if you remember. Well, the question asked in NEET 2021. BF3 is planar, all right, and electron deficient. Perfect. Hybridization and the number of electrons around the central atom, respectively, are. Quick. Guys, this is something which you should be able to solve easily. If I talk about your BF3, what is the type of this molecule? It is AB3L0. AB3L0. Or if you want to check the sigma bonds, it's forming 3 sigma bonds. There are no lone pairs. Steric number is 3 plus 0, 3. Hybridization involved is sp2. What else do you need? You have checked the hybridization sp2. And in case of your BF3, BF3 has got, boron has got how many valence electrons here? Boron has got how many electrons in its outermost shell here? 6 electrons in its outermost shell. So it's electron deficient, right? So sp2 and 6 is the correct answer. sp2 and 6 is the correct answer. The question asked in your NEET 2021, even this sort of a question you should be able to solve on your own. Even this sort of a question you should be able to solve on your own. Choose the correct answer. Choose the correct answer. First of all, PCl5. PCl5 is AB5L0. AB5L0, trigonal bipyramidal. Trigonal bipyramidal. SF6. SF6 is of the type AB6L0, octahedral. Octahedral. BRF5. AB5L1. AB5L1. It is square pyramidal. It is square pyramidal. C, you are going to connect with 1, right? And BF3, there is only one left. That is trigonal planar. Now you have to match the options and do it. Done? All right, NEET 2018. In the structure of ClF3, I think this is the data of the previous question, so avoid this particular data. Look at the question now. In the structure of ClF3, the number of lone pair of electrons on the central atom of chlorine. Let me show you first of all, if you do not know how to check the lone pairs, etc., how to check the type, let me show it to you. See guys, chlorine being the central atom, how many valence electrons it has? 7. How many surrounding atoms? 3. Number of surrounding atoms is equal to number of sigma bonds. So chlorine, it has 7 valence electrons and it has utilized 3 valence electrons. Chlorine, it has 7 valence electrons and it has utilized 3. So 4 are there as such in the form of 2 lone pairs. So sigma 3, lone pair 2. Steric number has to be 3 plus 2, 5. Hybridization involved is sp3d. Type of the molecule is going to be A. Now 3 sigma bonds and 2 lone pairs on central atom, AB3L2. Now I think your answer is clear. There are 2 lone pairs on the central chlorine here. You all are perfectly right. You all are perfectly right. Look at this question. The question has been asked in your NEET 2018. Again, this is something which you should be able to solve. Which of the following molecule represents the order of hybridization? sp2, sp3, sp. See guys, this particular carbon, it is forming 3 sigma bonds. 2 with hydrogen, 1 with carbon. So it's sp2. This one, 1 sigma, 2 sigma and 1 with hydrogen. It's again sp2. This is sp2. This is sp2. Look at this carbon, 1 sigma, only 2 sigma. 2 sigma means sp. So sp2, sp2, sp. That means it has to be option 2. That has to be the correct answer of this question. Again, a simple and basic question this is, people. Again, a simple and basic question this is. And I'm again repeating the same thing. If you have watched the chemical bonding marathon, which I've taken almost 1 month before, on this particular channel itself, in the game of NEET 2.0, you would be able to solve each and every question on your own. Trust me on that. If you are just following the notes. The species having bond angle 120. Bond angle 120 means what has to be the type of the molecule? AB3L0. Because in case of your AB3L0, your bond angle is what? Your bond angle is 120, 120. So where do you see AB3L0 type? It's option C. Right? It is option C. Option C is going to be the correct answer of the question. All right. Which of the following species are isoelectronic and isostructural? Isoelectronic means same electrons. Isoelectronic means someone is asking, no, they ask sp2, sp3, sp. Wait, let me check that question again. What have they asked? They have asked sp2. No, here is a mistake. It's sp2 only. Here is the sp2. You just have to modify it. It is sp2 here only. It is sp2. Because this is sp2. This is also sp2. Here it's sp and here it's sp. Right? Then only you will be getting the second answer as the correct here. Right? And this is the common question, guys. This you would have seen in a lot of your modules, books, etc., etc. Even I'm solving this question for the 100th time. Right? Okay, moving ahead. The question was, which of the following pair of compounds is isoelectronic? Isoelectronic means same number of electrons. Isoelectronic means same number of electrons. Number 1. Number 2, isostructural. Isostructural means, how do you check the isostructural ones? In order to check the isostructural ones, check the type of the molecule. if the type of the molecules is same, the molecules are supposed to be isostructural. Check the type of the molecule. If you look at the second option, your IBr2 negative. IBr2 negative. First of all, let me check the type of this particular molecule. My dear students, if you talk about this iodine as a central atom, it has got 7 valence electrons. There's a negative charge, so 7 plus 1 makes it 8. There are 2 surrounding atoms, that means 2 sigma bonds. So how many lone pairs are there? 8 minus 2, 6. 1, 2, 3, 4, 5, 6. So there are 3 lone pairs. If there are 3 lone pairs, the type of the molecule is AB2L3. So this is the type of the first molecule. Now check your XCF2 here. Now check your XCF2 here. Xenon. It has got how many valence electrons? 8 valence electrons. How many surrounding atoms? 2 surrounding atoms. So how many lone pairs on xenon? 3 lone pairs. The type of the molecule again is going to be AB2L3. So since the type of both the molecules is same, so they are going to be isostructural and they are isoelectronic as well. They have same number of electrons as well when you check it. Okay, they are isoelectronic as well. So it has to be option 2. That is the correct answer of this particular question. Something very basic, something very casual question, right? It's a bonus question, I would say. Predict the correct order of electron repulsions. Lone pair, maximum. Followed by lone pair, bond pair. Followed by bond pair, bond pair. This is something which you would have studied from your class 11th, right? Lone pair is maximum, followed by lone pair, bond pair, followed by bond pair, bond pair. Sir, are you in Bangalore? No, I'm not in Bangalore. I'm home. I'm in Kashmir. Perfect. Perfect, guys. All right. NEET 2016. NEET 2016. Hybridization in case of NO3 negative. In case of your NO2 positive. In case of your NH4 positive. How do I check it? How do I check it? First of all, check the type of the molecule. Or leave the type of the molecule aside. Let me show it to you clearly. How many valence electrons with nitrogen? 5. There's a negative charge, so 5 plus 1 makes it 6. How many sigma bonds do you see? Number of surrounding atoms is equal to number of sigma bonds. Oxygen being divalent, that means there will be no lone pair on nitrogen. Sigma 3 lone pair 0. Steric number is 3 plus 0, 3. Hybridization involved is sp2, right? NO2 positive. Valence electrons. 5. There's a positive charge, so subtract 1, so 4. Sigma bonds are 2, right? Oxygen being divalent, so all the 4 valence electrons would be utilized. So 0 lone pairs. Steric number 2 plus 0, 2. Hybridization involved is sp. Now, NH4 positive. Nitrogen. How many valence electrons? 5. Minus 1, 4. How many 6 surrounding atoms? 4 surrounding atoms. 4 valence electrons, 4 surrounding atoms. So all valence electrons utilized. So no lone pair on nitrogen. Steric number 4 plus 0, 4. Hybridization involved is sp3. So it's sp2, sp and sp3. sp2, sp and sp3. sp2, sp and sp3. So this is the answer of the question. Perfect. I hope I'm clear with this. All right. NEET 2015. NEET 2015. This sort of a question, guys, again, I mean, you should not take a lot of time to solve this question. It's again easy question. Which of the following species contains 3 bond pairs and 1 lone pair around the central atom? 3 bond pairs and 1 lone pair. Yeah, it is this one. No? Your PCl3. If you talk about your PCl3, how many valence electrons phosphorus has? 5. How many surrounding atoms are there? 3. So out of 5, 3 are used. So 2 are left in the form of 1 lone pair. So 3 sigma bonds, 1 lone pair. That's something which I was supposed to check. 3 bond pairs and 1 lone pair around a central atom. Yes, PCl3. Yeah? Done and dusted. Done and dusted, people. Done and dusted. Look at this one. Look at this one. In which of the following pair, both the species have sp3 hybridization? sp3. Where? Both have sp3, they are saying. Both have sp3, they are saying. This is something which you should be able to solve. Simple question this is. Which of the following pair both have sp3 hybridization? What do you think? What do you think? What do you think? People are coming up with option 3. Is that? Is that? Is that? Let's check it out. My dear students, if you look at option 3, talk about this particular species, NF3. How many valence electrons with nitrogen? 5. How many sigma bonds? 3 sigma bonds. Out of 5 valence electrons, 3 are utilized. So 2 electrons are left in the form of a lone pair. Steric number is 3 plus 1, 4. Hybridization is sp3. Now, talk about your water, H2O. How many valence electrons with oxygen? 6. How many surrounding atoms here? 2 surrounding atoms means 2 sigma bonds. So out of 6, 2 are used. So 4 are still left in the form of 2 lone pairs. So there are 2 lone pairs. Steric number 2 plus 2, 4. Hybridization involved is sp3. So the correct answer of this particular question is going to be option C. Perfect. Simple basic questions they've asked. All right. Look at this question carefully. Carefully solve this question. You might do a mistake here. In the regular octahedral geometry of MX6, regular octahedral geometry, this is how your octahedral geometry looks like. I hope you all remember this. These atoms are present on one plane. These atoms are present on one plane, and this is one perpendicular to the plane and one more again perpendicular to the plane. This is your regular octahedral geometry, you know it. What do you think? How many XMX 180 degrees are there? I want to see your answers first. Guys, this is something which we have done in detail, right, in the marathon of chemical bonding. And you should not take a lot of time to solve this question. Very simple. It is very, very, very simple. Quick. If you look at this particular one, XMX, this is X, this is M, and this is X. So this is 180 degree. 180 degree. Now, look at this one. X, M, X. It's again 180 degree. Look at this one. X, M, X. This is again 180 degree. So how many 180 degrees are here? The answer is going to be 3, right? Option C is the one which is correct. AIPMT 1999, when you were not even born. Look at this question. Which of the following has the pyramidal shape? Pyramidal shape. Pyramidal means AB3L1 type. AB3L1 is pyramidal. Now, which one is AB3L1 type? If you talk about your SO3, sulfur has got 6 valence electrons. No, it cannot be SO3. Sorry. Look at your PF3. Phosphorus has got 5 valence electrons, right? How many surrounding atoms? 3. So 3 sigma bonds. How many lone pairs? Out of 5, 3 are utilized. So 2 electrons are there with phosphorus in the form of a lone pair. So 3 sigma 1 lone pair. The type of the molecule is AB3L1. And if the type of the molecule is AB3L1, the molecule is supposed to be pyramidal in shape. Right? Absolutely. It's option 4. It's option 4. Why you are saying BF3? BF3 is AB3L0 type. It's triangular planar. Triangular planar. Right? You should know it. Okay. The question asked in JEE Mains 2023. List 1 is molecules, ions. Number of lone pairs of electrons on the central atom. Okay. Number of lone pairs of the electrons on the central atom. First one is your IF7. If you talk about your IF7, iodine has got 7 valence electrons, right? 7 surrounding atoms, so 7 sigma bonds. No lone pair on iodine. Right? So in case of iodine, there is no lone pair. In case of IF7. So 1 you are going to match with 4. A you are going to match with 4. Okay? ICl4 negative. ICl4 negative. Iodine. 7 valence electrons and negative charge, 7 plus 1, 8. Sigma bonds are 4. Out of 8, 4 are used. So 4 are still there in the form of 2 lone pairs. So there are 2 lone pairs on iodine in case of ICl4 negative. 2 lone pairs. 2 means 3. So B you are going to attach with 3. Right? Rest you need not to check because this is the only option matching it. So it has to be option 2. Perfect, people? I believe this is super clear to everyone. I believe this is super clear to everyone. One more question asked in your JEE Mains 2023 and you should be killing this question, guys. Yeah? XCF4. If you talk about XCF4, XCF4 is of the type AB4L2. AB4L2. And AB4L2, you know, it is square planar in shape. Square planar. Is there any square planar? Yes. So A match with 2. A match with 2. Okay. A match with 2. Perfect. B match with 1. Okay. I'm not going to check B. I'll be directly checking C. NH4 positive. NH4 positive is tetrahedral. NH4 positive is tetrahedral. AB4L0 type. So B with C with 4. C with 4. So it has to be option D. Yeah? Sir, when will you do thermodynamics? Thermodynamics is already done. Check the playlist. Check the playlist. Oh, you're saying top 100 questions of thermodynamics. Top 100 questions of thermodynamics will be done on Wednesday. On Wednesday, 8 p.m. We'll be doing. See, Wednesday, Thursday, Friday. On all the 3 days, I'll be taking 3 sessions. Right? One is going to be your thermodynamics. One is going to be your equilibrium. And one is going to be your, this one, electrochemistry. 3 sessions I've planned for you. Wednesday, Thursday, Friday coming. Wave optics is happening on Tuesday. Coming Tuesday. Okay? Perfect, guys. Let's move on. Let's move on. What do you think? JEE Mains 2022. Quick. Number of lone pair of electrons on central atom and shape of BRF3 molecule. Your BRF3. Valence, first of all, valence electrons of bromine, 7. Right? It's a halogen family. 7. How many sigma bonds? 3 sigma bonds. So out of 7, 3 are utilized. 4 are still there in the form of 2 lone pairs. Right? Steric number, 3 plus 2, 5. Hybridization, sp3d. Type of the molecule, AB3L2. And AB3L2, AB3L2, it's going to be T-shaped. Right? It's going to be T-shaped. So 2 lone pairs and T-shaped. Is any option like that? Perfect. Perfect, guys. I think this question we already solved. NO2 negative, NO2 positive, NH4 positive, right? This is something which we solved a few minutes back only. I think it was repeated here. Okay. Look at this one. The ion that has sp3d2 hybridization. The ion that has sp3d2 hybridization. What do you think? I need an answer from you. I need an answer from you people. Quick. I need an answer from you. Quickly, quickly. Quickly, people. sp3d2. If you look at this one, ICl4 negative. Talk about iodine. 7 valence electrons, negative charge, so 7 plus 1 makes it 8. How many sigma bonds? 4 sigma bonds. Out of 8, 4 are used. So 4 are still there in the form of 2 lone pairs. The type of the molecule is going to be AB4L2, right? Steric number here is going to be 4 plus 2, 6. And when the steric number is 6, the hybridization involved is sp3d2. When the hybridization involved is sp3d2, which d orbitals are involved in hybridization? D is z square and dx square minus 5 square. You should know it, right? It's simple. Option 3. Option 3. Sir, why don't you teach coordination compounds? Coordination compounds is already taught by ma'am, Sonali ma'am, right? So the chapters which are already done by your Sonali ma'am and HSP sir, have not touched those chapters. Okay, perfect. Check that coordination compounds by Sonali ma'am. That is one amazing session which you are going to love. Okay. Isomerism is done by HSP sir. Isomerism has been done by HSP. All right. Perfect. I'm moving on. I am moving on. One question again in your JEE Mains 2022. And simple question this is. Tell me the answer. Till then, I can have some water. Oh, you're saying question practice. Question practice, I'll do. Question practice for all the chapters, I'll only do. For organic also, inorganic also, physical also. Question practice, I'll be doing myself. Tell me the answer of this one. Which chapter questions we are going to discuss in the next session? It's going to be thermodynamics. Thermodynamics. All right, guys. If I talk about these particular species, XeO3, xenon being the central atom, so 8 valence electrons. How many sigma bonds? 3 sigma bonds. Oxygen being divalent, so 3 2s are 6. So I would say 2 electrons are there in the form of one lone pair. Hybrid steric number is going to be 3 plus 1, 4. What do I have to check, by the way? The number of lone pairs. So there is one lone pair on this xenon. XeOF4. XeOF4, right? So 8 valence electrons with xenon. How many sigma bonds? 4 plus 1, 5. Right? So 4 electrons used here, 2 by oxygen, 4 to 6. So 2 will be left in the form of a lone pair of xenon. So there is one lone pair here. XeF6. XeF6. Xenon again has got 8 valence electrons. So 6 sigma bonds. Therefore, one lone pair. So one lone pair here. So what is the what do I have to check? The sum of number of lone pairs. So 1 plus 1 is 2, 2 plus 1 is 3. So the answer of this particular question has to be 3. Answer of this particular question has to be what? It has to be 3, guys. Right? It has to be 3. All right, a quick question. A quick question for you. A quick question for you. Tell me. A quick question for you guys. Everybody. Everybody, let me know in the chats quickly. What is the answer of this particular question? I told you few seconds back only, I told you, I believe. Few seconds back. The hybridization is your D2sp3. In case of your D2sp3, which orbitals are used? Which d orbitals are used? Dz square and dx square minus y square, right? So it is option A, which is going to be the correct answer of this particular question as well. Let's move on to one more. What do you think about this one? Again, a simple basic question. We have discussed this in detail in the marathons. Quickly, people, quickly. Everyone. Quick. People are saying option 2, 3, 2, 3. Guys, it's ASF5 or ASF6? It's ASF5, okay. ASF5. ASF5, right? ASF5. How many valence electrons? 5. How many sigma bonds? 5. How many lone pairs? 0. What is the steric number? 5 plus 0, 5. Hybridization, sp3d. If hybridization is sp3d, so s orbital, your px, py, pz, and dz square. These are the orbitals which are involved in the intermixing, right? So it is s, px, py, pz, and dz square. So this is the question. Done and dusted, people. Done and dusted. Tell me the answer of this question. Tell me the answer of this question. Tell me the answer of this question. Quick. Tell me the answer of this particular question. Quickly. What do you think? What do you think about this particular question? What do you think about this particular question? Our thermodynamics problem practice session I'll be doing on Wednesday, guys. Wednesday it's going to happen, yeah? Okay. First of all, you tell me the answer of this question. Quick, everybody. Are you saying A? Absolutely, A is the answer, right? HOH bond angle in water is 104 degree 5 minutes, not 109 degree 28 minutes. Because of which of the following? Because of the lone pair repulsion in case of water, right? Oxygen has got 2 lone pairs, perfect. So there'll be two lone pairs on oxygen, due to which there'll be lone pair repulsions, and therefore the bond angle in case of water is not 109 degree 28 minutes, it's 104 degree 5 minutes. Yeah, so it is option A, and A for apple, right? Moving ahead. Tell me the answer of this question. Quick. Again, it's a simple question. Select the correct statement regarding the shapes of PCl5, BR5, BRF5, and IF7. Quick. Quickly, guys. Quickly. Basically, somebody was distracting me here. Okay, so that's why I was smiling. Quick. So, PCl5 already you should be knowing. This is something which we have discussed many a times now. It's AB5L0 type. So, it has to be trigonal bipyramidal. In case of your BRF5, its type is AB5L1, so it has to be square pyramidal. Then you have got IF7. IF7, it's a simple one. It is AB7L0, so it's going to be pentagonal bipyramidal. The question is, one of the given compound is square pyramidal. Yes, one of the given compound is square pyramidal. Done and dusted. Moving ahead, guys. Moving ahead. Check this particular question. What do you think? What do you think about this one? You should be able to do it quickly. Quickly, guys, what do you think? People are saying option D. Is it C, D, what? The question is among the following, which statement is the wrong? They are not saying which statement is right. What are you doing? They are saying which statement is wrong. It has to be option C, guys. There is, I mean, in case of your CH4, CH4 is of the type AB4L0, so it has to be tetrahedral, right? It is tetrahedral. When it comes to your SEF4, SE belongs to oxygen family, 6 valence electrons, 4 sigma bonds, so it's AB4L1 type. It is AB4L1, so it has to be seesaw. So their shapes are different. They are saying they have got same shape, which is not possible. So it's option C. Yeah? They were asking about the... Okay, is option D also wrong? Is option D also wrong? You're saying I3 positive. Let's check I3 positive also. Let's check I3 positive. I3 positive I can write as I2 positive for the simplicity. Valence electrons of this iodine are 7 and positive charge, so 7 minus 1, 6. Surrounding atoms are 2. So out of 6, 2 are used. 4 are still there. So there are 2 lone pairs. Perfect. So 2 sigma, 2 lone pairs. So it is AB to L2 type. AB to L2 means bent. It's correct only. It's not wrong. Correct. This is not I3 minus. Guys, you're taking it wrong. This is not I3 minus. This is I3 plus. This is I3 plus. This is I3 plus. Which spammer has come now? Akansh. Somebody. Yes, Akansh, you're right. You're right. You can leave. You can get the hell out of my class, bro. You're blocked. Thanks for coming. Okay. Perfect. Let's move on to one more. Check this particular question. Check this particular question, guys. Tell me the answer quick. CLF3. CLF3. CLF3, the number of lone pairs of electrons on the central chlorine. CLF3. Chlorine being the central atom, 7 valence electrons. How many sigma bonds? 3 sigma bonds. Out of 7, 3 are used. So 4 are still there in the form of 2 lone pairs. So there are 2 lone pairs on the central chlorine, right? There are 2 lone pairs on the central chlorine. I believe I'm clear. Yeah? Yes, all of you are perfectly right in this question. Good job, guys. Identify the wrongly matched pair. Identify the wrongly matched pair. This is again something which you should be able to solve. NH3 we have discussed many a times. NH3, it is pyramidal in shape. It's right. Trigonal pyramidal. PCl5. PCl5 is trigonal bipyramidal. It is trigonal bipyramidal. But here they have mentioned trigonal planar. So this one is wrong. This is incorrectly matched. So it's option 2 that's correct. This is incorrectly matched. PCl5 we have been discussing many a times now. Your PCl5. It is sp3d and trigonal bipyramidal. Of course, option 2 is incorrectly matched. All right. All right. Just a second. Just a second. Check this particular question and I want answers from you. Check this particular question and I want answers from you. Quick, quick, quick. Who is sending these spammers today? Who has paid them? Who has paid them? A lot of spammers are coming. But they do not know I have got the option to block too. Yeah, I'm not on their platform where they have to call the IT team to block the people. One click away. Yeah, I don't have to call anybody. I'm here. Quickly, guys, this question you have to solve on your own. Wait. What are you doing? I want the answers in the chats quickly. I want the answers in the chats quickly. Session will end at 10, I guess. Let's see. People are saying option 1, no? Let's see. First of all, if you talk about your CH2, CH2, here the hybridization of your carbon is your sp2. It is sp2 hybridized. Now you have to check in which of the following species the hybridization involved is sp3. Sorry, sp2. So talk about CO3 di-negative. Is it sp2 only? Which of the following species has the same hybridization as that of carbon here? 2 sigma bonds with hydrogen, 1 sigma bond with carbon, so sp2. Okay. So I have to check which of the following has got sp2 hybridization. CO3 di-negative. So valence electrons of carbon are 4 plus 2 makes it 6, right? Sigma bonds are 3. Oxygen being divalent, so 3 2s are 6. All the 6 are used, so no lone pair. So steric number is 3 plus 0, 3. Hybridization involved is sp2, right? So it has to be option A only. There is no need to think a lot in this question. No need to think a lot about this particular question. Okay? Perfect. Identify the molecule that does not exist. Identify. By the way, the PDF of this particular session you will be getting on my Telegram. Wassim Bhat Chemistry Official is the name of the Telegram channel. Wassim Bhat Chemistry Official, right? Be the part of that Telegram channel, and the PDF, the handwritten PDF of this particular session, I'll be sharing there after the session. Identify the molecule that does not exist. The question based on your MOT. A very, very, very common question. It is He2 that does not exist. Why is that? Because when you write the molecular orbital configuration of He2, in case of one helium atom, there are 2 electrons. So 2 helium atom means 4 electrons, right? Means 4 electrons. So its molecular orbital configuration is sigma 1s2, sigma star 1s2, right? And bond order formula, you already know. Half of number of electrons in bonding minus number of electrons in anti-bonding, right? Perfect. So bonding, anti-bonding, 2 minus 2, that's 0. And when bond order, you must be knowing when bond order comes out to be less or equal to 0, the species is non-viable, the species does not exist. So it has to be option 4. That is the correct answer of this particular question. That is the correct answer of this particular question. Quickly about this. What do you think? Check this particular question, guys. Check this particular question. Sahana, I'll let you know when I'll be taking GOC. Right now, you can consult the GOC chapter from Game of NEET 1.0 only. Okay? Well, for the bond order, if you remember, I had given you one trick. I hope you remember that. If the total number of electrons are 14, for the 14 electron species, the bond order is 3. 15 electron species, the bond order is 2.5. 16 electron species, the bond order is 2. 17 electron species, the bond order is 1.5. 18 electron species, the bond order is 1. Similarly, 13 electron species has got the bond order of 2.5. 12 electron species has got the bond order of 2. 11 electron species, 1.5. 10 electron species, the bond order of 1. Now, NO, nitrogen has got 7 electrons, oxygen has got 8. So 8 plus 7 comes out to be 15. So it's a 15 electron species, and 15 electron species have got the bond order of 2.5. Cn negative, 7 plus 6 is 13, 13 plus 1 is 14. 14 electron species has got the bond order of 3. Cn positive, 7, 6, 13. 13 minus 1 is 12. So it's a 12 electron species. 12 electron species have 2. This has to be Cn. 7 plus 6. 7 plus 6 is 13. 13 electron species have got the bond order of 2.5. Which of the following has got the highest bond order? It's Cn negative, which has got the highest bond order. So its bond order is 3, right? Simple and basic again. right? It has to be option 2. That is correct among all. Okay, look at this one. Look at this one. Guys, this is something which all of you must be knowing. Bond order is directly proportional to bond dissociation energy, is inversely proportional to bond length, right? Which of the following has got the minimum bond length? Minimum bond length means maximum bond order. Minimum bond length means maximum bond order. O2 positive, it is a 15 electron species. O2 negative, it is a 17 electron species. O2 dinegative, 18 electron species. O2 16 electron species, right? Now, just check their bond orders. Check their bond orders. Check their bond orders. Few minutes back only I told you the trick. 16 electron species has got the bond order of 2. 18 electron species has got the bond order of 1. 17 electron species has got the bond order of 1.5. 15 electron species has got the bond order of 2.5. So maximum bond order, minimum bond length. Maximum bond order is here in case of O2 positive. So it will be having minimum bond length. Perfect. Perfect, people. The number of species showing diamagnetism. Diamagnetism. Again, you have to write the molecular orbital configuration of each species, and wherever configuration you will find the unpaired electrons in the molecular orbitals, that's going to be paramagnetic. Wherever you see filled configuration, completely filled configuration, that's going to be diamagnetic. Well, if you talk about N2 you are given with N2 positive, you are given with N2 negative, you are given with O2, my God, you are given with O2 positive, O2 positive, you are given with O2 negative, you are given with O2 dinegative. When you write their molecular orbital configurations, let me tell you, O2 has got 2 unpaired electrons, right? O2 has got 2 unpaired electrons, O2 positive has got 1 unpaired electron, O2 negative has got 1 unpaired electron. This has got 0 unpaired electrons. And similarly, guys, you can check the rest too, right? You just have to write the molecular orbital configuration. And when you write the molecular orbital configuration, right, that molecular orbital configuration which does not contain any unpaired electron, that's going to be diamagnetic. And that molecular orbital configuration that contains the unpaired electron, that's going to be paramagnetic in nature. Correct? This is something which we have discussed too in the marathon. I've shown you how to write the molecular orbital configurations of different species. Yeah? Perfect. NCERT exercise question. What do you think about this one? What do you think about this one? Compare the relative stability. You know, your bond order is directly proportional to stability. Your bond order is directly proportional to stability, right? You know it already. And you must be knowing if two species have got same bond order. If the bond order of two species is same, then that species which has got more anti-bonding electrons, its stability is considered to be less. Again, this point is something which we have discussed, right? Again, this is something which we have discussed. Quick. O2, O2 positive, O2 negative, and O2 dinegative. We have to arrange them on the basis of their relative stability. O2, O2 positive, O2 negative, O2 dinegative. O2 has got 2 unpaired electrons. O2 has got 2 unpaired electrons. O2 positive has got 1 unpaired. O2 negative also has got 1 unpaired. This has got 0 unpaired electron. 0 unpaired electron, number 1. Number 2, we have to talk about their stability. Say, O2 is a 16 electron species, so its bond order is 2. Right? O2 positive is a 15 electron species, its bond order has to be 2.5. O2 negative, 7 electron species, bond order 1.5. O2 dinegative, bond order 1. Right? So more the bond order, more the stability. Where do you see the bond order more? O2 positive. So O2 positive is going to be maximum stable among all. Right? O2 positive is going to be maximum stable among all. Perfect, guys? Am I clear with this? Everybody? O2 positive has got maximum bond order among the all. So O2 positive is going to be maximum stable, right? And here you have got 2 unpaired electrons, paramagnetic. 1 unpaired electron paramagnetic, 1 unpaired electron paramagnetic, 0 unpaired electrons diamagnetic. This is again something which can be easily done. What do you think about this one? What do you think about this particular one? Quickly. The correct order of bond orders. C2 dinegative. Your C2 dinegative is 14 electron species. N2 dinegative is 16 electron species. O2 dinegative is 18 electron species. Correct? The correct bond order. 14 electron species has got the bond order of 3. 16 electron species has got the bond order of 2. 18 electron species has got the bond order 1. So, I would say C2 dinegative here has got maximum bond order, followed by your N2 dinegative, followed by your O2 dinegative. Is there option like that? O2 dinegative, N2 dinegative, C2 dinegative. So, it has to be option 2. That is going to be the correct answer of this particular question. That is going to be the correct answer of this particular question. What do you think about this one? What do you think about this one? The bond order and magnetic behavior of O2 negative. O2 negative means 17 electron species. 17 electron species have got the bond order. 16 electron species have got a bond order of 2. So this has got 1.5, right? O2 has got 16 electrons, so 2 unpaired electrons. So this has got 1 unpaired electron. 1 unpaired electron means paramagnetic, right? So bond order 1.5 and paramagnetic at the same time. 1.5 and paramagnetic. Yeah? Absolutely. Done and dusted. This question, I mean, you should flood the chats with the answers, with the correct answers, I mean. You should flood the chats with the correct answers of this question. Quick. Everybody. Which of the following is paramagnetic? I've told you many a times now, O2, 16 electron species has got 2 unpaired electrons. 2 unpaired electrons means paramagnetic. Yeah? Perfect. Which of the following pair of species have same bond order? Same bond order. You must be knowing by now, isoelectronic species, they have got the same bond order. Isoelectronic species have got the same bond order. Now, which one is isoelectronic? Your Cn negative. 7 electrons, 6 electrons, 7 plus 6 is 13, plus 1 is 14. It's a 14 electron species. CO, 8 plus 6 is again 14, so again a 14 electron species. So these two are isoelectronic. If they are isoelectronic, their bond order has to be same. And you know, bond order of 14 electron species is 3, right? So it has to be option B. That is the correct answer of this particular question, right? Right, people? Am I clear with this? Am I clear with this? Am I clear with this? What do you think about this one? What do you think about this one? What do you think about this one? The common features among the species Cn negative, CO and NO positive. Well, it's Cn negative. Carbon has got 6 electrons, nitrogen 7. 7 plus 6 is 13, 13 and negative. 13 plus 1 is 14. It's a 14 electron species. 8 plus 6, 14 electron species. 8 plus 7 is 15, 15 minus 1 is 14. So 14 electron species. So these three are what? These three are your isoelectronic. And if they are isoelectronic, their bond order has to be same. And 14 electron species have got bond order of 3. So all the 3 species will have bond order of 3. So bond order 3 and isoelectronic. Done? Done, people? This is the last question of the session, and this is your homework question, guys. You are going to let me know its correct answer in the comment section of this particular video. Comment section, not in the chats. I want the correct answer of this particular question in the comment section of this particular video, not in the chats. Perfect. So these were the top 100 questions from the chapter chemical bonding, which involved all the NCERT exercise questions, all the NCERT in-text questions, all the NEET PYQs, all the JEE Mains PYQs, all the AI PMT PYQs which have been asked from this particular chapter, right? And I believe the ones who have watched the marathon properly, the ones who have watched the chemical bonding marathon which I took last month, you would have solved majority of the questions, I believe, on your own. Yeah? If yes, then do let me know in the comment section of this particular video. Do let me know that you were able to solve these questions on your own, at least majority of the questions. Do let me know about that in the comment section of this particular video. And this particular answer of this question, I would again want in the comment section. And our next session is going to be on Wednesday, and the chapter name is going to be Top 100 Questions of Thermodynamics. So it's going to be Wednesday, Thermodynamics Top 100 Questions we shall be doing, which will involve all in-text, all NCERT, as well as all JEE Mains and NEET PYQs, which have been asked from that chapter. Right? And the session PDF of this particular session, I will be giving you on my Telegram, which is Wassim Bhat Chemistry Official. Perfect. Answer of this session I would want in the comment section, and in the comment section do let me know whether you were able to solve majority of the questions on your own or not. So with this, I'm taking a leave. I'll see you guys on Wednesday. Till then, you guys take care. God bless you all and love you all, guys. Bye-bye. Take care.